Righto, we're going to talk today about adding fractions, and there's only one real rule you need to remember. You must have the same denominator on the fractions you are adding. That's fairly obvious. If you think about adding a third and a half, we can't add them together because they're not the same size. So basically the rule is convert so you've got a common denominator if there isn't one already. Add the numerators, simplify if you need to, and then depending on whether you're asked to give it as a mixed or an improper fraction, give it as a mixed or an improper fraction. So the example we've got down here, 1/5 plus 2/5. If we actually think about what that means, we've got 1/5, so we've taken a whole and we've divided it into 5 equal pieces. I've got one of them. And then I've got a whole that I've divided into 5 equal pieces and I've got 2 of them. So I've got 1/5 and I add 2 more. Obviously, I have 3/5. So here's another example for us. 2/7 plus 6/7. If I've got 2/7 and you give me 6 more, I've then got 8/7. Now, because it hasn't actually told us to give it as either an improper or a mixed, you can choose. I actually prefer improper fractions because they tell me more information. But if we wanted to convert this to a mixed number, we say to ourselves, how many 7s are there in 8? Well, there's 1 and 1 left over. Alright, what happens when we don't have a mixed common denominator at the start? Then what we need to do is we need to create equivalent fractions with common denominators. So I've got 1/3 and a half, plus a half. I can't add those the way they are. I must make 1/3 and 1/2 into equivalent fractions with the same denominator. So I need to find the lowest common denominator. And the lowest common denominator is the lowest common multiple of 3 and 2. If you remember how to find lowest common multiples, basically what we do is you write out the multiples of each one, or just a few anyway. So the multiples of 3, the multiples of 2 are 2, 4, 6, 8, 10, 12, etc. Now you can see in those two lists there are two multiples that are the same so far, and they are 6 and 12. Now obviously 6 is the lowest common multiple, and that has to be the denominator of our fraction. So what we need to now do is convert 1/3 and a half into 6. So make equivalent fractions with denominators of 6. So we say to ourselves, what did I do to the 3 to get to the 6? Well, I times it by 2. So 1/3 is the same as 2/6. And we need to do the same to a half. We need to make that into 6ths. I multiplied the denominator by 3, so I have to do exactly the same to the top. So a half is the same as 3/6. Now I have a common denominator. I can add the fractions and I get 5/6. Obviously at this point you should simplify, but that is in simplest form already. Alright, so those steps again. First of all, find the lowest common multiple of the 2 or more denominators. If you've got more than 2 fractions, you have to do it for all of them. Create equivalent fractions with the lowest common multiple as the denominator, then basically add the fractions. So in this case here, 1/6 plus 1/4, I need to find the lowest common multiple of 6 and 4. Now for all those of you saying, oh, it's 24. It isn't actually 24, but I'll show you it doesn't make any difference in a second. So write out the multiples of 6, 6, 12, 6, 18, 24, etc. Multiples of 4 are 4, 8, 12, 16, 20, 24, etc. So yeah, 24 is a common multiple, but it's not the lowest. The lowest common multiple is 12. So I need to make equivalent fractions with a denominator of 12. So quite obviously, to get from 6 to 12, I've multiplied by 2. And I need to do the same with the quarter. I need to make that into 12ths. So 1/4 is 3/12. So instead of 1/6 plus 1/4, I write it as 2/12 plus 3/12, which is 5/12. Now, that's in simplest form already. If you had said, well, yeah, I could have just multiplied the 2 and I will always get a common denominator. You're right, we will always get a common denominator. But what you need to be careful of is that you simplify at the end. So I'll do that as another example. So if we went, well, instead of using the lowest common multiple, we'll just multiply the denominators. Then I'll show you what happens. So if we went, well, 1/6, I know a common multiple is 24. So multiplied by 4, multiplied by 4, that's 4 24ths. And 1/4, to get to 24ths, I have to multiply by 6. 6 24ths. So this becomes 4 24ths plus 6 24ths, which is 10 24ths. And that's fine if you simplify by dividing the top and bottom by 2, which gives us 5/12. So it's okay to use the multiple of the two denominators, provided you simplify at the end. However, there is a reason why we shouldn't use the multiples of the two denominators sometimes, and that is because if you do, you end up with very big unwieldy numbers. So if I said, oh yeah, I'm going to just multiply the two denominators here, I have to work out what 12 times 18 is. Now, that's a big number. What 12 18s are? Well, 12 12s are 144, 6 12s are 72, add the two together. Too hard. So we should use common denominators where possible. So in this case, find the LCM of 12 and 18. That's 12, 24, 36, and I've already seen it, 18, 36. So the LCM is 36. So I need to make my equivalent fractions with the denominator of 36. This is 5/36 plus, sorry, not quite right. So 5/12 I need to convert into 36ths, and 7/18 I need to convert into 36ths. So 5/12, obviously I've multiplied the bottom by 3, so do the same to the top. So it's 15/36. 7/18 I've multiplied the bottom by 2, so do the same to the top. It's 14/36. Then I can write them as 15/36 plus 14/36 equals 29/36, which you should then simplify, but 29 is a prime number, so that is in simplest form. That's a lot easier than doing 18 times 12 and then simplifying at the end. So don't always multiply, but if it's taking you ages to actually find the lowest common denominator, you can always multiply to find a common denominator, and that's often the case if you've got more than two fractions. Alright, here's an example of where, once again, where you wouldn't want to multiply. So we can find the LCM of 20 and 25. So the lowest common multiple is 20 and 25. Well, that's 20, 40, 60, 80, 100, and I can stop there because I know that the multiples of 25, one of them is 100. So the LCM is 100. So 15/20 has to become something over 100, and 6/25 has to become something over 100. So to get from 20 to 100, I multiply by 5, do the same to the top, 5 15s are 75. To get from 25 to 100, I multiply by 4, do the same to the top, so that's 24/25. So this becomes 75/100 plus 24/100, which is 99/100. Now, is that right? 5 7 is 24. It is. We possibly could have done this. No, we can't. That's fine. So it's very important that you always check your answer and just make sure that it's right. When I wrote this question, I thought, oh, I could simplify that first, but it gives me quarters, not fifths, so that's fine. Alright, the only other one to throw in the works is sometimes when you have mixed numbers, a lot of people fall into the trap of adding the whole parts, then adding the fractional parts and writing it as a combination of the two. Now that works when the fractional part is still less than 1, but in this case it won't be, so a good rule of thumb is to always convert to improper fractions first. In any operations with fractions, if you convert to improper fractions, you'll never run into trouble. If you need to give the answer as a mixed number, you can always do that at the end. So converting these to improper fractions, so 4 3/4 is the same as 4 times 1 plus 3 is 7 over 4, plus 7 and 11 twelfths. 12 times 7 is 84, plus 11 is 95 over 12. Alright, I now need to find the lowest common denominator of 4 and 12. Once again, don't fall into the trap of multiplying the two. So we need to find the LCM of 4 and 12. Well, multiples of 4 are 4, 8, 12, 16, etc. Multiples of 12 are 12, 24, 36, etc. From that list, obviously the lowest common multiple is 12. I don't even need to change my 95 over 12. So all I need to do is say, well, 7 over 4 equals something over 12. I've multiplied the denominator by 3. Do the same to the numerator. 21 over 12. So this is the same as 21 over 12 plus 95 over 12, which gives us 116 over 12. Okay, if you give that as your answer, it's not quite correct. And the reason it's not quite correct is because we can simplify. And remember, when you're simplifying, you're looking for the biggest number that goes into the numerator and the denominator, or the highest common factor of both. It's not obvious to see in this one. I'm not sure where the 4 goes in. So I could always divide by 2. So if I divide both the top and bottom by 2, 116 divided by 2 would be 58, and 12 divided by 2 is 6. Now they're both still even numbers, so I could do it again. So 58 over 6 is the same as 29 over 3. So that tells me at this stage here, I could have divided by 4. (116) divided by 4 is 29. And no, it's not. Should be. It is 29. And 12 divided by 4 is 3. So it doesn't matter if you don't do it straight away, as long as you keep simplifying until you can't go anymore. Now, if they ask for that as a mixed number, how many 3's in 29? There are 9 with 2 left over.